from Group 5. Today we would like to present about the roof collar at Sultan, Mizan and Abidin. My name is Muhammad Nabil bin Abdul Ghani.
And my name is Zainal bin Abdul Rashid.
My name is Zainal bin Tanwa.
My name is Alif Shah.
Next. For introduction, the stadium is located in Gong Badak, Terengganu, and is viewed as a major sport and public infrastructure project and supported by reinforced concrete element. However, a large portion of the roof collar after completion. This roof collar is two times. For the first deck collar is 2 June 2009 and the second roof collar at 20 February 2013. It the capacity for 50,000 spectators. This station raised a serious cost of the regard of the safety and the integrity material of the stadium.
So let's go for the details on the types of material chosen. So the roof collapse is because of a lot of factors. So this I focus on in this case because the contractor used the no compliant steel, which is the steel is very wrong. Use the wrong composition. So it was installed and of course it reduced the strength and weldability and leading to the roof collapse. So the roof was built using a steel space frame, a 3D network of steel tubes connected at the joints that called nodes. So it used the low quality and then does not meet the original specifications. So as you can see, the main material is carbon manganese structural steel, which is grade S355. S355 is mean the minimum yield strength for this steel. So these are the compositions that inside the steel. It use carbon, manganese, silicon, phosphorus and sulfur. So every element has their own role, which is the carbon main strengthening the element. But as you remember, the high carbon can make the material more brittle. So it's of course it's hard to weld. And manganese is too low, it reduces the toughness. And the silicon phosphorus, the silicon is assessed to reduces weldability. In fact, it's wrong. So phosphorus and sulfur, it must be in keep the low quality for the composition. So the height of this material can cause the brittle and fatigue cracks. So this structural design for the space frame components. So there is 4 components, which is circular hollow section, bolts, spherical nodes, high strength bolts, and anti-corrosion coating. So this is the function of the hollow section. It carries the compression and tension forces across the roof span. So the roof, it can be directly forces and focus on the both the spherical nodes. So every direction, it focuses to one place. So transfer force between all connected tube members. So this is the most critical part because of there is a lot of forces that is being at in one place. So for the high strength bolt, they use grade 8.8 and 10.9. It fasten tube to nodes at the specified pre-tension load. And the last one is anti-corrosion coating. So it protects it from the moisture and rust in the tropical climate. So why the structural steel was chosen? There is a lot of reason, which is high strength to weight ratio, and ductility, weldability, and design flexibility. So high strength to weight ratio is strong enough to span 100 above meters without being too heavy. So as you know, the capacity of the stadium is 50,000 seats for this stadium. And for the ductility, it can be bent and deformed before breaking. So it gives you the visible warning. So for the design flexibility, it can be fabricated to complex 3D space and weldability, the members can be precisely welded at node connections on site, creating strong continuous load. So these types of material degradation and failure involved in this case. So structural buckling, fatigue failure, corrosion degradation, and wet joint failure.
For the roof collect condition, for the main material involved, the first one is the structure cell members, and the second board and welding connection, and the third roof covering material, and the last reinforced concrete support. For the involved, the effect the failure like excessive deformation, buckling of steel members, connection failure, and possessive collapse. That means is one connection is failure, the load is transferred to other connection. So the overall the connection will be failures.
Okay, so these are the physical properties of the materials that is chosen, which is structural steel. So firstly, we talk about the density, which is around 7,800 kilogram cubic meter. So basically it provides high structural stability and is suitable for large span structures. Next is the coefficient thermal expansion, which is 12 times 10⁻⁶ Celsius. Basically, the steel will expand when heated and contracts when cooled. So because of this, there might be this might be one of the considerations that makes the roof of the stadium to collapse, because they didn't take the coefficient of thermal expansion in calculations. Furthermore, the thermal conductivity is around 45 to 60 watts per meter cube. Basically, the steel transfers heat efficiently throughout the structure. This influences temperature distribution in the roof system. This is also one of the important factors, as Malaysia is a hot tropical country. Next is the specific heat capacity, which is around 470 to 500 joules per kilogram per basically, it will absorb and stores thermal energy effectively and reduces sudden temperature fluctuation and helps maintain thermal stability of the structure. Next. And then the melting point, obviously this is not taking into accountability because we still cannot melt under the sun. And then next, the electrical conductivity. This one, it conducts electrical current effectively, which is important to create some grounding system so that it will avoid it by electrical fires or any protection from lightnings, as Malaysia sometimes has really heavy thunderstorms. And then it is moderate to corrosion resistance. So this is also one of the factors that we just talked about just now. One of the factors that the roof to collapse is because the corrosion. Basically, it's vulnerable to corrosion in humid environments. This is obvious as Terengganu is almost at the seaside, which means that the environment is very humid, which can create corrosion for the steel to be rusted. So this such material needs protective coating such as epoxy paint, or maybe regular maintenance is very necessary to prevent any further deterioration. And then finally, when it comes to environmental suitability, it performs well in large infrastructure projects. Tropical climates can accelerate corrosion and thermal effects, and also long-term performance depends on proper protection and maintenance, of course.
So for this slide, we discuss about microstructure of material used in the stadium roof system. Here the main material that use structure steel, wet steel connection, reinforced concrete. So for structure steel, the microstructure consists of ferrite and pearlite. For ferrite provide good ductility and toughness. Pearlite contribute to higher strength and hardness. This combination of this phase provide a balance between strength and ductility for load bearing application. So for wet steel connection, the microstructure consists is base metal, heat affected zone, and wet metal. So the heat affected zone is the most critical region. So welding defects such as porosity, cracks, and incomplete penetration may reduce joint strength and fatigue resistance. The last one is reinforced concrete. Microstructure consists is cement plate, fine and coarse aggregate, pores and micro cracks, and embed steel reinforcement. So excessive porosity and micro cracking can reduce concrete strength and durability. Corrosion of reinforcement may occur of moisture penetrates through cracks. Here the summary of mechanical properties and microstructure of materials. So the material we use structural steel roof, bolt connection, weld connection, reinforced concrete support, and roof covering materials. So these mechanical properties for structural steel roof: height, tensile strength, good ductility, good toughness, and load carrying capacity. And for microstructure, ferrite and perlite, possible failure in stadium roof, buckling, leading deformation, and fracture. For bolt connection, the mechanical properties is required height shear strength, tensile strength, bearing strength, and fatigue resistance. Steel bolt structure usually like carbon or alloy steel microstructure. And possible failure, bolt shear, loosening bearing, failure, connection slip. Next is weld connection, required good weld strength, toughness and fatigue resistant. For microstructure, base metal, weld metal, and heat affected zone. For possible failure, weld cracking, brittle has failure, incomplete penetration, and fatigue crack. For the second last one is reinforced concrete support. So high compressive strength from concrete and high tensile strength from steel reinforced. Cement for microstructure is cement paste, aggregate pores, micro cracks, and steel reinforcement. For possible failure, cracking, crushing, spalling, reinforcement, corrosion. The last one is roof covering material. The material properties is lightweight, protects from weather, carries smaller load compared to steel frame. And the microstructure is depend on materials type, usually sheet or panel structure. Possible failure is steering, detachment, deformation under load.
Quality of the Sultan, Mizan and Abidin stadium. Okay, during that time, the stadium was built with inadequate temporary support framework, which I can categorize into three factors. First, we have the contractor maybe use substandard welding practices, insufficient prefabrication quality checks, and substandard material usage, like what Faris had just taught earlier. And the ultimate part which that lead to this failure is NDT was not done. Okay. So I want to do some geometry analysis. So basically, the roof of the stadium was built using this kind of geometry, which we call space truss structure. This structure heavily depends on the assembly of 3D geometry frame, which the mechanical properties of truss member and the nodes is very critical. Also, we cannot deny about the boundary condition of the support joint, which design geometry is as crucial as the part of the structural integrity. So because of this massive frame size, it will include some factor that may lead to the failure, which first you have wind induced dynamic loading, which is we know that Terengganu has very strong wind at any time throughout the year. Second, the support and joint strength, and lastly the thermal movement across the frame. So what I try to propose here, the material preparation and geometry construction. So first, the steel members of the frame should undergo rolling process for a controlled wall thickness and diameter. So as we know, rolling process is included in the strength hardening, where rolling process is used to fabricate any product where the product we can harden the surface of the product lah. So then after the rolling process, the product should be cut into desired line. We thread on the tubular product, tubular part of the product, and assemble into space truss frame like in the picture in front. Then as you can see here, there is a steel ball joint should also undergo forging or casting to make it harder and stronger. Then we will machine the joint precisely to connect the threaded end of tubular members. So here I want to propose 3 engineering solution. So my first solution, like what Faris has said earlier, new material application which is S355, which this material is categorized in high strength alloy steel. It has high toughness, good wearability. It is made from controlled microalloying and thermomechanical rolling, which this process affect the microstructure of the steel. It will refine the grain size, arrest propagating cracks, avoid sudden brittle fracture. Then my second solution I would like to propose is a non-destructive test, which this is very crucial. It needs to be done to detect any internal weld defect before the structure is loaded with people or anything lah. So this test we can detect such as porosity and incomplete fusion. So this is 2 example of NDT. We have ultrasonic testing and radiographic testing. And lastly, for the final or the ultimate solution, after the fabrication of the stadium, we should install structural health monitoring. This should be installed in structure to provide continuous and real-time monitoring. So when I propose this one, the sensor should be installed at the critical members and nodes. When this sensor capture reading exceed the threshold value, it will trigger alert for inspection, and it will allow us to know when to do preventive maintenance, and this will enable corrective action.
Sabar. For the conclusion for this presentation, the root collar is important for engineering failure case. However, steel has high strength and toughness, but it still can fail. First factor is the design is poor, connection are weak, workmanship is poor, and supervision insufficient. How to prevent this cylinder failure? Use the proper safety factor and loads analysis. And second, apply strict quality control during construction. And lastly, conduct regular inspection and maintenance. The overall safe infrastructure needs good design, good material, and continuous monitoring. That's all for my group. Thank you.